Alright, so we're going to be looking at standard deviation today. So far we've seen middle pieces. We've been able to figure out where the middle is in data. We've used medians, we've used means, we've even used mode. One thing that was quite interesting with medians is that we could also find the quartiles. So we were able to figure out essentially we were able to structure the data and figure out how spread it was, because if I'm able to take 25% of the data and stick it before the first quartile and then take 25% and have the median and then take 25% and third quartile, blah, 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 we're able to see how far or how tightly packed the data is between the quartiles and how it behaves with respect to the mean. So if the interquartile range is small, that means you have densely packed data. And if it's large, what we have is we have quite a wide spread, and that allows us to determine that. However, we don't. This is all reliant on being able to essentially put everything in order and find a quartile, find a third quartile, find a median, and group it together like that using the same logic as the median. But we haven't actually found how to measure spread with the mean. And this is where the standard deviation comes in. Because what we're actually able to do is, if I'm interested in how spread the data is, what I'm actually going to look at is I'm going to take the mean as my center point, and I'm going to figure out how far away my points are from the mean. So by doing this, we're looking at we have my point, and I want to figure out what the distance is from the mean of that point. So if this is if my point is above the mean, what this tells me is how far away it is from the mean. However, the problem is that I don't actually know if that's going to be positive or negative. So what we end up doing is we square it just to make sure it's always positive. So what this is going to tell me is the square of the distance between my point and the mean, and the reason we square it is to keep it positive. And then, so essentially what I'm going to do is I'm going to find, on average, how far away from the mean are my points. So I'm going to take this and use that logic, and I'm going to take all of them, and then I'm going to divide by the total number of elements. So I'm actually taking the mean of the distance from the mean. So what this will tell me is, on average, how far away is my point from the mean, and that will give us the same information as, on average, how spread is my data. And this is actually what we call the variance. And that's essentially it. What we do with the variance is we take every single point, take the mean away, square it, and then add all those together, add all the distances together, and then divide by the total number. So we mean the distance from the mean. Now, this would take a very long time to calculate, and it turns out, I'm not going to go into it here, but if you just mess around with this mathematically, another way of actually doing this is to essentially add all the squares of my values, find the mean of the squares, and then take away the square of the mean. So we can't really go into too much detail at this stage, but this is exactly the same thing as this, but I can work a lot more with this, because what this is this just tells me I square all my values, add them together, and then take away the mean squared. And this is the variance. We've figured that out there. Now, just to make things even more complicated, for some reason, we also can call the sum of, just in brackets here, we can call the sum of the distance between a point and the mean, we can call that the summary statistic. this can sometimes be given to us in an exercise question, so technically the variance is also the summary statistic divided by n. So these are all different ways of writing the variance, equally as valid. That we have this one here, we have this one here, which is kind of the same as this. And then if we're given the summary statistic, we just have to divide it by n. Now, honestly, one of the ones we'll use the most is this one. But then we haven't even talked about standard deviation. One of the things we did here was we squared it in order to make sure it was always positive. So it turns out the actual distance away from the mean is going to just be the square root of the variance in order to bring it back to like an actual palpable distance. So the standard deviation can therefore be written as the square root of the sum of x minus x bar squared divided by n, which is my primary definition here, or I can write that as the square root of the sum of the squares over n minus x bar squared. Or technically, if I'm given the summary statistic, I can write that as this one. Now, honestly, I can't go into too much detail about this notation, the SXX. Honestly, I don't think it's actually worth using at this stage. It comes in handy when you're dealing with much more complicated concepts in statistics, especially when we start looking at correlation and stuff. But I wouldn't have taught it to you if I had the choice, but the problem is the exam could tell you SXX is equal to, therefore we have to understand what it means. The most important one, however, is this one here, because we will be able to calculate the mean and square it, and we'll also be able to square every single term, add them together, and divide by the total number of terms. This is actually achievable using our calculators, using just our general knowledge. So essentially what it is the average distance away from the mean. I just want to emphasize that again. That's what it all comes back to. So I'm now going to do an example with this, yeah, we can see how to use it. So I'm going to use some editing magic, and I'm going to just like that, we have ourselves an example, which we're going to use this formula up here that we looked at for the standard deviation to calculate the mean and standard deviation of this data. Now, you can use the context, you can read it. There will generally be a question that involves you to use the contextual knowledge. However, in this case, we're just going to crunch the numbers. So essentially, the first thing you always want to do in this kind of question is calculate the mean. Now, this is nothing new. We can just literally take the time and multiply it by the number of people who got that time. We have to remember that's what frequency actually means. So we're actually doing 5 people scored it in 14 minutes, plus 18 people did it in 15 minutes, plus 25 people did it in 16 minutes, plus 29 people did it in 17 minutes, plus 13 people did it in 18 minutes, and then we want to divide by the total number of people. Now, in this case, they very unhelpfully have not actually given us the total number of people participating, but we can always calculate that just by adding all the numbers together. We have 5 plus 18 plus 25 plus 29 plus 13. That gives us 90. Now this won't always be a nice number. 90 is nicer than most, although it will still give us a weird number in the end. And just by typing this in our calculators, and we get 163 over 10, which is, well, we don't even need to use the calculator. 16.3 this time exactly, which is nice. Now, it's always worth actually looking at your data to make sure it makes sense. So 16.3 is actually somewhere in there. And also, it seems like around the midpoint, so that works about right. So what we're going to do is we're now going to say the standard deviation is equal to the square root of the sum of the x terms squared divided by n minus that squared. But first of all, I need to find all the terms squared. So we're going to do this first, and what this is going to be is going to be essentially the frequency multiplied by the term squared. So that is going to be, instead of 5 times 14, we're going to do 5 times 14 squared. Now we have to remember to square the actual value and not the frequency, which is why I wrote this in a nice order. So this is 18 people now got 15 squared, and then 25 people now got 16 squared, and then 29 people now got 17 squared, and then 13 people got 18 squared. So you know what, I'm going to do this, and I'm going to divide this by 90, and this will give us the much less nice, it's not a word, number of this, which we can then round in this stage to 266.9 blah blah blah, but I'm going to reuse the exact value when I type it into the standard deviation, so that the standard deviation is now equal to that number, because that is all of that. That's my 24023 over 90 minus this number, 163 over 10 squared, and that is going to give me the distance of the average distance away from the mean that this data takes. We are going to get 1.11, correct to 3 significant figures. But I do want to hammer home essentially what this actually signifies. This number means that on average, people did it in 16.3 minutes, but on average, in addition to that, on average, people were 1.11 minute off of this. So what that means is that a lot of my data is grouped around that, and that makes sense because I'm only dealing 14 to 18. But what this means is the spread of that is it's essentially, I can kind of say on average, it's this plus or minus 1.11, because a lot of people were, the average distance from that mean is actually 1.11. And there we go. Cool.